Hello everyone, this is the second part of lecture 3. First of all, let's talk about membership. Membership is a relationship between an element and a set. For example, if you have a set A and the members of which are 1 to 5, we use this same symbol to represent 1 is an element of. So this could be we read this as 1 is an element of set A. We use this symbol to represent not an element of. So 6 is not an element of set A. Notice that the result is the truth value. And we can have a relation between sets as well. For example, if we have these 4 sets, set A 1, 2, set B 1, 2, 5, and set C is an empty set, we have 2 ways to represent empty set. And D is a set of 6 and 7. Okay. The first relationship between sets are subset. The definition of which is that set X is a subset of Y if every member of X is also a member of Y. So in our example, A is a subset of B because all the members in A, 1 and 2, are also member of B. We have 1, 2 here. And the tricky point is here, C is an empty set. There is no member inside C. So C is also a subset of B. Actually, an empty set is a subset of every set. And D is not a subset of B because the member of D are 6 and 7. And 6 and 7 are not a member of B. And notice that subset has a property of identity, which means that every set is a subset of itself. So A is a subset of A. Okay. And a very similar concept is proper subset. We use this symbol to represent this concept. The definition is some set A is a proper subset of some set B if all elements of A are elements of B, but not all elements of B are elements of A. This definition is kind of complex. Actually, the difference between subset and proper subset is this identity. So, the proper subset will exclude the possibility of identity. So A will not be a proper subset of A. However, A is a subset of A. Okay. And notice that the relation that we have between sets, subset, proper subset, if we have two, the result of them is a truth value. We can have operations between sets as well. The first operation is intersection. We use upside down U to represent intersection. Intersection can be roughly understood as the members in both A and B. For example, if we have set A 1, 2 and set B 1, 2, 3, 4, 5, the members in both A and B will be 1, 2. So the intersection of A and B will be 1, 2. Another operation is union. We use U to represent union. Union can be understood as the members in either A or D. If we have the union of A and D, okay. A is 1, 2, D is 6 and 7. The union of A and D will be 1, 2, 6, 7. Okay. And then we have difference. We use minus sign to represent difference. The difference can be understood as the member in B but not in A. Okay, so the member we have A and B. The member in B is 1, 2. The members in B are 1, 2, 3, 4, 5. And the member in A is 1, 2. We just take away the members of A. So B, the difference of A, B and A will be 3, 4, 5. Okay, another operation is complement. We use prime to represent the complement. The idea of complement can be understood as not A. Recall that we have a universal set. Universal set is all the possible elements in the universe. And a complement of A would be the difference of U and A. Okay, which is literally not A. Okay, so with A is 1, 2, and we have a universal set 1 to 7. We just take away 1, 2 from the universal set, and we got this set. This set will be the complement of A. Okay, notice that the result of operation between sets would be a set as well. So union of A and B, intersection of A and B, or union of A and D, difference between B and A. This would be another set. Okay. We can have a summary here. I'll say these symbols will be connector of two things. The first one will be argument 1. The second one will be argument 2. Okay, if we have a set, we can use this set of connector. So this set of connectors, for this set of connectors, their arguments have to be sets as well, and the result would be truth value. What I mean by truth value is the result will be true or false. We can say A is a subset of B, and we have a truth value whether this statement is true or not. Okay, and we have other connector as well, the operator between sets, F, intersection, union, difference. The arguments of this connector will be sets as well. Okay, and the result is a set. Okay. The third type is the membership connector. The first argument of this connector can be a set or an element. However, the second argument must be a set, and the result is truth value. Okay, this is the end of lecture 3, and now you are able to work on quiz 3. See you next time.